Hello everyone, today's essential learning is that compound inequalities involve either the overlapping or the union of two inequalities. So let's look at an example. Let's look at what this means. So there's really two situations. Either we're looking for where two inequalities overlap, and in the left-hand side here, the graph of compound inequalities with the word "and" is really referring to the overlap. You basically are looking for where both inequalities are true. So if we look at two separate inequalities, x greater than or equal to 3, represented by the line above, or x less than or equal to 7, represented by this line, if we wanted to look at where both of those inequalities, it'd be where they overlap. So if I kind of like drew a vertical line down, this region here between them is where they overlap. And so that's going to tell us that the inequality shown on this number line, this interval here, is both. It is x is greater than or equal to 3 and x is less than or equal to 7. That is the overlap of those two regions. On the other hand, the graph of a compound inequality that contains the word "or," it's where either graph is true, where either one exists. So for the graph x is less than -2, we see it there. For greater than or equal to 1, we see it there. So this graph on the bottom is the places where either of them exist. Neither of them exist in the middle range here, but the first inequality exists over here, the other inequality exists over here. So one or the other, and typo right there, that should be the word "or," one or the other exists on all the points that we marked on this final and third number line here. One other thing to note is that you can write a compound inequality involving "and" as a single inequality, sometimes called a conjoined inequality. So up above we saw the inequality written this way with the word "and" literally separating the two inequalities. Well, we can actually rewrite this almost as kind of like a little sandwich for x, where x is between the values 3 and 7. So notice in both cases, the alligator is eating x instead of the 3, and the alligator is eating 7 instead of the x. You always want it to be the least value on the left and the greatest value on the right. So that is a conjoined inequality. You cannot conjoin an "or" inequality, only for the cases of "and" inequalities. So let's look at writing some compound inequalities from some phrases. So it says all real numbers that are greater than -2 and less than 6. So we can write greater than -2 and less than 6. We could even go ahead and conjoin those. If you need to, you could take one step and kind of flip this around, keeping the alligator pointing towards the n on this inequality. Then we kind of see the n's here in the middle, and they kind of just merge together into one n. And then here on the number line is the graph result between -2 and +6. We can do the same thing for an "or" inequality. There's no way to conjoin it, but we can say all real numbers that are less than 0. Okay, there's our first. Or greater than or equal to 5. So there's our second, and we can represent those on the number line below. So let's go ahead and do another example here. All real numbers that are greater than or equal to -4. That's going to be n is greater than or equal to -4, and n is less than 6. So those are our two inequalities. If we wanted to, we could write those as a conjoined inequality. -4 less than or equal to n less than 6. Make a number line here. We'll put those key numbers, -4, 6. Notice I'm not going to make every number in between or try to make a perfectly accurate scale. I'm just going to throw the important numbers on there. Filled in circle there, open circle there. Try to make it bold enough so that we can see that it's clearly the region in between. For part D, all real numbers that are less than or equal to 2.5. So n is less than or equal to 2.5. Or n is greater than 6. Okay, can't conjoin those, so we're just going to go to our number line here. So I'm going to put 2.5 here, 6 here. So it's got to be less than or equal to 2.5, so closed in circle there. And we're going to go to the left, and an open circle here, and to the right. Great. So next time we'll look at how we actually go ahead about and solve some compound inequalities.